I'm going to show you the secret trick to winning Punch-a-Bunch every single time. Wait, is that Jackie Chan?
I'll take him out. Just punch away. 2. Because you just won $25,000.
The game consists of 3 distinct sections. First, contestants play a game of higher or lower on 4 items. For each correct guess, they earn a punch. The second section is where contestants get to practice their best karate moves by punching through the 5x10 grid where the prize slips are hidden. The prizes range from $100 all the way up to $25 grand. They don't make it easy though. Only a single slip contains the top prize. The final section is where contestants find out what they've won. They must decide to keep their cash or risk it to see the next slip. No matter what you choose, you're at least going to walk away with something. Unless, of course, you can't even figure out how much a banana costs.
I mean, it's one banana, Michael. What could it cost? $10?
With 845 games played, we have a sad win rate of 6%. But don't sweat it too much. The wins are only defined by the players who have won the top prize. First airing in 1978, Punch-a-Bunch is the first ever all-cash game. It's been streamlined since the original airing, which featured 2 punches a guess, and also at one point incorporated a second chance system. It's now much easier for contestants to walk away with a prize. But sometimes the game has ran into some issues. In 1989, Sandra Smith punched an empty hole. Not knowing what to do, Bob took the advice of an audience member and gave her the top prize.
That's absolutely the only thing we can do. You win $10,000.
The game was featured on Ellen back in 2010. The top prize was a trip to Orlando. And can you believe it? The contestant found the slip with no help at all. Now that we know the history, let's build it. If you want to follow along or see the end results, I've included the links to my GitHub and the live site in the description. Let's import all of our images and create our high-low objects. Each object will contain a name, a fake price, the real price, and the image. Our items include a hydration station, cake stand, slicer and wedger, thermometer, wine set, photo scanner, weights, and speakers. When the game starts, there's a few things we'll want to track, starting with the earned punches. When we should move to the next section, the amount of items seen during higher or lower, what the current item is, and let's include the used items as well. We need a function to kick off our game. So let's start by setting all of the use states to their initial values and increase the high-low count by 1. We also need to create a getRandomItem function, that way we don't have the same order of items every time we play. We do this by getting all the items we haven't used yet, pick a random item, mark it as used, and finally assign it to our item variable. We also included a backup in case there aren't any items left, but that's unlikely to happen. Let's drop that random item creator into our start game function. The other functions we should add are for returning to the home screen, getting the next item, starting the Punch-a-Bunch section, adding a punch, we can't forget that one, and of course, using the punch. Let's pass all these down to the correct components and get started on our high-low game. We'll want to create a couple more use state variables here, one for the real price and our display message. Now let's add some more functions. When a guess is submitted, we want to compare the fake and real prices, and set the message accordingly. We should probably display the real price at this time too. This use effect is going to hide our real price and message whenever the state of our item changes. As long as the item count is less than 4, this next function will continue to give users new items. If it equals 0, then the return statement will render the button to start the game. We should probably inform our users how to actually play the game, so let's add that to our app file. Inside our main return, we'll want to conditionally render our message in the correct color, depending on the user's guess. We can also use a ternary statement here to show the real price. We'll use the same technique to render the high-low buttons and the continue button. The functionality is ready, now we just need to style it. I won't be going through all of this here, but like I mentioned earlier, the code is in the description. Looks like everything is working properly. Did I mention that this game is mobile friendly too? Now it's time for the main event, the creme de la creme, the punch. And if you don't think that it's that important, then you should ask Reddit user KM44, because they're not fucking around when it comes to punching around. The first thing we need to do is add all of our prize values and the amount of times they appear in the board. We can add 2 more use states to track our selected circles and our remaining prizes. To shuffle our prizes, let's use the Fisher-Yates algorithm. And if you're not familiar with these two, don't worry. Imagine this. You have a new deck of cards and you want to mix them up so they're in a different order. The Fisher-Yates shuffle is like when you close your eyes, pick a card, and then swap it with the card in your hand. You do this for all the cards, one by one, moving backwards. This use effect will automatically shuffle the prizes at the start of the game, since it runs when the component is first mounted. Finally, we need to create a function that handles our user's punch. To create the game board, let's render a 5x10 grid. We'll want to use a ternary here to represent when the user punches a circle and change the background. Something doesn't feel right. I know. Let's change our cursor into a fist. Or better yet, let's give the option to select a fist. Inside our top title component, we can create an object with our images. We'll have a large image for displaying the choice to the user and a smaller one for the cursor. This one has to be 32 by 32 pixels. All that's left is to map over these objects and create a function that allows us to select an icon. We're only going to display this to our larger screens since phones don't have a cursor. You'll want to wear these instead. It's now time to build the prize reveal. This is where the contestant finds out what the prize of each punch was worth. We need a way to track the current index and if the game is over. We'll want to be able to access the value of our object, so let's create a new variable here. Next, we need a way to enable the contestant to keep their prize. This will effectively end the game with the current value as their prize. If the user wants to continue opening remaining slips, we'll first check to ensure that there actually is a prize in the array. We'll add a use effect here that will run every time the selected circles and current index values change. Lastly, let's give the user a way to play again. Now we'll quickly style this component and test it out. We'll also be adding in our end card for when the user keeps their prize. We'll also add our favorite confetti NPM package to add a little flair at the end. It looks like our game is finished, so I can finally reveal the secret trick to winning every single time. Just increase the count. In all seriousness, our algorithm will make it impossible to really cheat on this game, and I assume the same can be said for the crew at The Price is Right. The best you can do is maybe slip somebody backstage at 20. Or go on Ellen. Hey, you made it to the end. Let me know what game I should cover next, and of course, don't forget to like and subscribe. See you next time.